Welcome to this explainer. I am so thrilled to have you with us today as we unpack a really fascinating intersection, aerospace engineering meeting the deep sea environment. We're going to be looking at a sunken space relic. Just think about it. An engine, literally the size of a small house, that once roared into the heavens. What actually happens when it spends a half-century buried in the abyss? Now, real quick, just a heads up before we dive in. The scientific visuals we'll be exploring today are AI-generated representations. They aren't meant to depict one specific confirmed historical engine, but they do give us a highly accurate visual synthesis of exactly what happens to this kind of advanced technology when it's left at the bottom of the ocean for 50 years.
So I really want you to take a second and just picture this scenario. Imagine a massive, unbelievably powerful rocket engine. This is a machine designed to harness controlled explosions, right? Designed to roar through the atmosphere. And now, it's resting completely silently on the pitch-black ocean floor. It's the ultimate contrast. You have this incredible piece of technology, born in literal fire and intense heat, and now it's subjected to the freezing, crushing depths of the sea for 50 years. What actually happens to it? Does it survive down there? How does the ocean claim it?
Section 1. The Deep Sea Discovery. A silent resting place.
The sheer visual transformation here is absolutely staggering. After nearly 50 years underwater, this engine looks nothing like the pristine, polished machinery you're used to seeing on the launch pad before liftoff. It becomes completely buried in time. Over the decades, fine layers of ocean sediment drift down, slowly and relentlessly, burying entire lower sections of the engine right in the muck of the seafloor. And whatever surface area is lucky enough to remain exposed, well, it doesn't stay bare metal for long. It gets entirely colonized by marine organisms. The engine basically stops being a machine and just becomes part of the ocean's geography.
Section 2, Nature versus Space Engineering, when ocean meets aerospace.
To really grasp the scale of this transformation, we need to look at the engine nozzle. The nozzle is that massive, iconic, bell-shaped structure right at the base of the rocket. Think about what its original extreme function was. During flight, it channels exhaust gases that burn hotter than lava, literally hotter than lava, to produce the immense upward thrust needed to push a heavy rocket right out of Earth's atmosphere. It was built to withstand unimaginable heat and pressure.
But fast forward 50 years, and that exact same nozzle, the one once filled with fire, is now just a convenient attachment surface for marine life. It has essentially become an artificial reef. It's covered in barnacles, draped in algae, and crusted completely over with coral-like organisms and other marine growth. The contrast is just, wow. It's a powerful reminder that, to the ocean, our greatest technological achievements are really just newly available rocks to call home.
So the really crucial point here is how the actual materials hold up to this harsh environment. Saltwater is notoriously aggressive, but, it definitely plays favorites. Standard steel components, they'll develop heavy, destructive corrosion. They essentially just rust away, totally losing their structural integrity over the decades. But aerospace engineering utilizes some highly advanced materials. Parts made from certain nickel-based alloys and specialized stainless steel actually have much better survival rates. They fiercely resist the saltwater's attack, which is exactly why, half a century later, some parts of the engine remain remarkably intact while others have basically just dissolved.
Section 3. Inside the sunken engine. Saltwater's relentless attack. Now, a rocket engine isn't just a hollow bell, right? It is packed with incredibly complex internal mechanics. And beneath the sea, all these intricate components face severe internal deterioration. We're talking about massive turbopumps that used to force fuel into the combustion chamber, super delicate valves that controlled pressure, literal miles of complex pipes, and highly calibrated fuel injection systems. I mean, obviously none of these were designed to be submerged in corrosive saltwater for 50 years.
And saltwater is incredibly opportunistic. It exploits every single vulnerability it can find. It enters into the absolute smallest openings and microscopic cracks in the machinery. Once it gets inside, it accelerates corrosion from the inside out. But even worse, it specifically targets and weakens the joints where different types of metals meet. Because of the different electrical potentials of various metals, saltwater acts as an electrolyte. It actually creates this galvanic reaction, like a little battery, that actively eats away at those crucial connections. So the ocean is literally dismantling the engine piece by piece.
Section 4. Identifying the historical wreckage. Underwater detective work.
Now, despite all of that heavy degradation just talked about, major components actually often remain recognizable to the trained eye. Engineers and underwater archaeologists approach this whole thing almost like a high-stakes crime scene. They're looking for very specific clues to solve the puzzle. They meticulously study the nozzle geometry,
like the exact angles and curves of the belt. They map out the plumbing arrangements because different engine models had highly unique layouts for all those pipes and valves. They analyze the specific manufacturing methods used, which can help date the tech. And incredibly, they actually search for surviving serial markings stamped right into those resilient nickel alloys we mentioned earlier. By piecing all these tiny clues together, they can successfully identify the exact make, model, and sometimes even the specific historical mission of that wreckage. It's brilliant.
Section 5. The Fragile Rescue Mission. Hauling history to the surface.
Recovering machinery of this size, especially in this condition, is a complete logistical nightmare. The extreme danger here really cannot be overstated. After 50 years of corrosion, the structure is unbelievably fragile. You can't just hook a cable to it and yank it up to the surface. Between the sheer weight of decades of accumulated marine life and the sudden change in water pressure as you lift it, pulling from the wrong stress point can cause catastrophic structural failure. One simple mistake in lifting, and you can instantly destroy a priceless piece of history before it even breaks the surface.
And the challenge absolutely doesn't end when it finally reaches the boat. Immediately upon recovery, experts have to enact a strict step-by-step preservation protocol. Step 1. Keep the engine wet. I know, it sounds totally counterintuitive to keep soaking a rusted machine, but it is absolutely vital. The engine has to remain saturated until proper chemical conservation begins. Step 2. Specialists must gradually and very carefully remove the accumulated salt from deep within the metal's pores. And then Step 3, they apply chemical treatments to stabilize the metal and halt any further decay.
So why go through all these meticulous steps? Well, because of the threat of air. This is a literal race against time. If a metal object that's been soaking in deep-sea saltwater for 50 years is suddenly exposed to oxygen-rich air without this strict treatment process, it triggers rapid, wildly aggressive corrosion. The metal will quite literally start flaking apart and disintegrating right in front of your eyes. Without immediate and sustained conservation, simply exposing the engine to the air would permanently destroy the exact historical evidence they just worked so hard to recover.
As we wrap up today, it's really worth reflecting on what this wreckage truly represents. A rocket engine found underwater is so much more than just twisted metal. It is, to quote the experts, a preserved chapter of spaceflight history, showing both the power of human engineering and the slow, relentless effects of the ocean. It's just a profound juxtaposition, right? On one hand, you have the absolute pinnacle of human ingenuity, designed to literally conquer the stars, and on the other hand, you have the quiet, inevitable, and overpowering patience of nature, just slowly reclaiming it all. Which leaves us with a final thought to ponder. If an artifact as massive and historically significant as a space-age rocket engine can just sit silently on the ocean floor for half a century, what other chapters of human history are resting silently in the deep, just waiting to be discovered? The ocean holds onto its secrets tightly, and it seems like every time we dive down, we learn a little bit more about our own incredible journey. Thank you so much for joining me on this explainer today, and hey, keep exploring.